This video is focused on one of the main causes of orbit failures, torquer jamming. Before we can understand jamming, let's understand what a torquer is. You will never see these in the field as they are located inside the control collar, highlighted in red here. If you'll notice the two sets of anchor bolts, this is where the control unit is attached. In the next scene, we'll take a look at a disassembled control unit in the shop and walk you through each component. After that, we'll talk about what causes jamming, possible methods to prevent it, and then how to identify and take action.
So this is the lower end of the control unit. The control unit is the brains of the tool. It's what orients the valve within the bias unit. Down here at the end is the mule shoe and mule shoe shroud. So the shroud simply protects the control shaft that engages inside of the mule shoe. The mule shoe in here actually has a kind of an alignment slot that mates up with the control shaft itself. And then this is pinned to the lower spindle. You see here that there's some roll pins. So this is a good example of what stick slip or shock can do to a mule shoe. It just erodes the holes over time, and so that if these pins break, you lose the link between the control unit and the bias unit. This is a hanger. So the hanger is what actually physically bolts to the collar and holds the control unit inside the collar. It's got two anchor bolts. You'd see these on the outside of the collar bolting into this hanger. So if you see a washed out of the hanger bolt or a crack in the collar in that area, it mounts into this hanger and you'll see subsequent wash on this area of the tool. These should rotate freely. So this is what allows the control unit itself to spin within the collar. And there's two of these, one on the upper and one on the lower. Well, that's the lower torquer and magnet housing. So this generates power and torque for the tool to steer. These rotate at about 2,000 RPM, downhole 1,000 to 2,000 RPM, depending on your flow rate. So that's why it's critical to stay within your operating flow defined on your OST, because that, based on the pitch of this impeller and how fast these need to rotate, you have to be within a certain flow rate range to achieve the RPM you need on these torquers. When you hear about torquer jamming, that means that this is no longer spinning freely, so it can't spin at 2,000 RPM. It means it's got friction in it and it can't rotate. So when we tear the tools down at the shop, they will either be seized or have a kind of a notchy feel that prevents them from rotating. So this is, they call it the labyrinth sleeve or the torquer shroud, either one. Essentially, there's a gap here between this mag housing and the pressure barrel, and this shroud just acts to protect that gap and require flow to go backwards to get into it, which is, ideally to keep debris out of the lower torquer instead of just being able to feed directly under it. So this is standard on all tools now since I think 2015. Above that's the pressure barrel. It's a titanium barrel that contains all the electronics, and then above that on the other side is the upper torquer. This is the upper magnet housing, which is on top of the upper torquer. The mag housing is simply the magnet part of the alternator. The torquer contains a three-phase winding which acts as an alternator. So that's how the tool can control its tool face, left and right, counterclockwise and clockwise, is based on the load it applies to this alternator, generating a specific amount of torque, which is controlled by the electronics. So this one again should rotate about 2,000 RPM. This one you'll see is a little bit loose, but it should be tight and should have just a minimal gap here at the bottom. Looks like this one's been abused a little bit. This is the upper hanger. Again, two anchor bolts. They go through the collar. You'll see these on the outside of the tool. So this is a broken down lower torquer. This is underneath the mag housing. So what we were just looking at, it has the blades at the top here. Those have been disassembled. This rides over the top of this, and this is what spins at 2,000 RPM. So inside here, you can't see them, but they're covered in a sleeve. This is just a bunch of permanent magnets. So just like in an alternator, you'd have magnets rotating around a stator, a coil of wire. This is the reverse. You just have the magnets on the outside. And then on the inside, underneath this, is the coils of wire. The three-phase winding that generates power and torque for the tool to steer. This spiral wire is called the scraper wire. All that does is while the magnet housing rotates on the outside of it, it acts to auger debris and everything out through there. So when torquer jamming occurs, It's between this surface and the ID surface of the mag housing. If it's caused by debris or something else, and that causes this to stop rotating, and you lose your steering response and your power.
Now that we have a clear perspective of how tight the tolerances are, let's get an understanding of what can jam these components. The biggest cause of jamming is metallic particles. As you just learned, the torquers use magnets to generate power and steer. These magnets tend to attract metallic debris. Other types of plastics, rubber, and wood. The drilling fluids also have low gravs, additives, LCM, and cement. These are all prime examples of what frequently jam orbits. Our best defense against jamming is preventative measures. At the top of the list is ditch magnets. It is recommended to run at least 3 and to place them in the shaker's discharge back to the active system. It is required to clean at least twice a tower or as frequently as needed. If you look at the image above, if you're this full of metallic debris, you might want to go a little more frequently until they start looking a little cleaner each visit, and then you can go back to twice a tower. Another preventative measure is filter screens, and they should be used on surface and downhole. Also, we must monitor the low gravs and try and keep them below 8%, and remember to avoid fibrous LCM. Last but not least is to stay above our minimum drill flow as per our OST. So this minimum drill flow, staying above that optimizes the flushing around those torquers to keep them free. Even though we follow our preventative measures to a T, jamming can still occur. This is evident when you have real-time comms by comparing your desired versus your effective. First, we'll look at tool face. The green is our desired and the red is our effective in the top image. You want these to lay on each other and stay consistent, as in we are steering in the direction we want to be. Next is making sure our steering ratio is within 10% of our desired setting. Lastly, the possum value is a good indicator of how hard the torquers are having to work to keep our tool face at the desired setting. This is illustrated by the green range between -80 and -30%. Anything outside of this range is our first indicator that some jamming is occurring. All 3 of these are evident in the image below. The tool faces are almost 180 out for 4 consecutive updates. You can see this by the green and the red arrows splitting. The steering ratio is only 50% of the desired. You can see our desired is 100% and we're only achieving 50% of that. And the possum is at a positive 40%. This is an example of the initial signs of jamming. Once identified, it's very important to take action immediately. It is almost impossible to free a locked up torquer. If we jump on it early, we have a better chance to remove the debris causing the friction. We do this by sending a low vis sweep immediately followed by a high vis sweep. This helps to agitate the lodged debris, then flush it out of the component with the high vis sweep. The sweep recipe is illustrated here. Each sweep should be about 20 to 30 barrels, and remember to ensure that the graphite added should be non-metallic. You can check this with a magnet. It is good practice to go over the recipe pre-job to make sure that 1, product is available, and 2, that the derrick hand on tower can build the sweep immediately. So this concludes our video of torquer anti-jamming. So always remember, prevent, identify, and act immediately. These are the key steps to a successful orbit run.